Hello, I'm Jagan from Grow with Data. Welcome to the Crack SQL Interview in 50 question series. In this video series, you'll practice 50 SQL questions across various topics. You can use the playlist Crack SQL Interview in 50 questions to follow the videos related to this series. For each video in the series, you can find the related code on my GitHub. Feel free to explore the code and provide any feedback in the comment section. If you want to see the code used in this video, then you go to the YouTube channel Grow with Data. You have the videos on the playlist. We are talking about Crack SQL Interview in 50 questions. If you want to see the Tamil version of it, you have Tamil Crack SQL Interview in 50 questions. So if you go into the playlist, you have all the videos related to this series. So if you go to the description part, there is a GitHub link which take you to the GitHub page. And for this video, we are talking about we have the select statement and the create table. All the script will be in the GitHub page. Okay. Now, if you want to join the WhatsApp channel, you can use this link and join Grow with Data WhatsApp channel. Now, let's see the data and you can talk about the question in detail. So, we are given the table accounts. Let's create this table. So, in this table, we have the account ID, which is the primary key, and then we have the income for each account. So, we are asked to write a solution to calculate the number of bank accounts for each salary category. So we are given a salary category of low salary, average salary, and high salary. So based on this category, we have to see how many accounts are falling under low category, average, and high based on the value. So if we say less than 20,000, then it's a low category. So if you see here, for all this four, this one is less than 20,000. So this is going to be low, and which is more than 500, then it's going to be high. So this is also going to be more than 500k, so this is going to be high, and then this is also going to be high. So out of three categories, we have one account for the low category and three accounts for the high category. There is no account for the average salary category. So what they say, the result has to be for all the three categories. If there is no account in the category, then you have to return 0 for this category. So what happens for low salary category? You got 1. For average, it's going to be 0. And for high salary, you are going to get 3. So how to get this? Let's comment this out and go into our coding part. So basically what you have to do, we have to categorize the income, and then you have to find the number of accounts falls under those categories. First, we start with categorizing the salary. So we say select, use a case statement, okay? So case when the income is less than 20,000, then it's a low salary category. If not, when the income is between 20,000 and 50,000, then it's average salary category. Average salary. And then if not, you can say else high salary. So these are the three main categories they mentioned. We can just say when the salary is greater than 50,000, then high salary, because we have the only this as the exception. We can just say else high salary. So everything which is not falling under these two categories will come under the high salary category. So we don't have to put another when class. We just say else. So this is category column. From the accounts table, and we need the count of accounts. Since account ID is a primary key, we don't see any duplicates. Account count. Since we use count, we just say group by the first case statement. So if you see this, you have the high salary as 3 and low salary as 1. So we got 3 and 1. But how will I bring in the average salary? For that, what I'm going to do is, I'm going to create a hard-coded table. So how will I create a hard-coded table? Let's see. I say select low salary as the first one, right? Low salary as category. If I run this, I will get one record. So low salary and the header is going to be category. Same way, I am going to add the two more. Union all. This is average salary, and then union all. The next one is high salary. So if I run this, I will get a table with 3 records. This is a hard-coded one. I am going to use this as the CTE table with all category as. I'm taking this as a CTE table, and then I'm going to have the second one as the given category. So this is going to be my second CTE table. Now I'm going to combine the all categories C left join with the given category as G on G dot. So G, we have the category here, right? So G dot category equal to C dot category. So what will happen? The all category will have all the 3 categories, and it's going to be left joined with this category. Now I'm going to say C dot category, and then I have to bring in the account count. So that is in the given category. G dot account count. So we are not doing any aggregation part, so don't have to bring group by. So if I run this, I get low salary, average salary, and high salary. But if you see this, if there is no record for average salary in the second CTE table, then it shows null. But we have to show 0. We should not show null. So what should I do? I can simply say coalesce function. If the value exists, bring that value, else you bring 0. So if I run this, I'll get the expected result. So low salary, I got 1 account. High salary, I got 3 accounts. And the average salary, it's from the hard-coded table, and it checks if that exists in the second CTE table. If don't exist, we use a coalesce function to make it 0. So we get the result. Now it works fine and not bigger issue, right? But thing is, we have 2 CTE tables, all categories and given category. Let's see if we can reduce that to 1 CTE table. So let's see if we can simplify the code. So we take the first hard-coded value, right? We get the hard-coded table that we can't change anything. If you have any lookup table or a single table you guys insert, you can just refer that. If not, you have to create a hard-coded CTE table here. Okay, so that part is done. Now I'm going into the second part. I'm going to select from all category again C left join accounts A. Now when I join here, I used the G dot category equal to C dot category, right? So G dot category is a case statement. So I'm copying the case statement as such on this equal to our C dot category. So instead of getting a CTE table and then use that column, I directly use the case statement and I connect that with the all category CTE table. Now I can use that select statement and I can directly get the result. So what I did, I have the CTE table for hard-coded categories, and then I directly connect that CTE table with the accounts table, and the join condition, I directly use the case statement, which I used for the categorizing, and then connect that with the CTE table. If I run this, it's showing error. G dot account count. Okay, so here we don't have G, we have A dot account count. Sorry, we haven't calculated that, right? So we have to do the calculation here. Count of account ID. We have to bring in that. So previously we used CTE table, right? So this is A dot account ID. So since we use count, we have to use group by 1. So when you do that, I got the expected result. So what I did, I completely removed the second CTE table from here, the given category. I remove that CTE table. Instead of that, I directly use the case statement which I use for categorizing and use that in the where class to connect. And then I calculate the count in the select statement directly and use the coalesce function to find the 0. So in that way, I completely reduce the CTE table. So it saves some memory to it. Great. I prefer going with the second category, but there are other options also. If the table is so small, right, and you are just doing for analysis purpose, you don't have to work much onto the performance part. Then there is another simple way to do it. Let's see how to do that. You just say select low salary as category, and then I am going to use the select statement directly here. Select count of account ID from you accounts where the income is less than 20,000. So I use this as a column itself as account count. So instead of using a subquery table, I directly use that in the select statement. If I run this, I get the low salary, which got one account. So I am going to use the same code, union all, get me for the average one. So for average, where the income between 20,000 and 50,000. So if I run this, I get for the low and average. So for high, the same thing. I can use union all, and I will say where the income is greater than 50,000. That will give me high salaries category. So I will get the expected result. The problem here is I am going to use the accounts table 3 times into this query, but it's so well defined, right? For low salary, I use the select statement with the particular specification, and for average, I use the select statement. The income is between this, and for high, I have a separate SQL. Though it takes the accounts table 3 times, the query is so explainable, right? So I have low, average, and high. So if I run this, I'll get the expected result. So this is one part of it. I can fine tune this code. Instead of going for a select, I will go like a if statement kind of thing. So how will I do the if statement kind of thing when you go with the accounts? I will say low salary as category, and then sum of accounts. Okay, so you just say sum of income less than 20,000 as account count. So how will this work? Let me just comment this out and show you how the select statement works here. So if you get only this first one and you run this, sum of income less than 20,000 accounts from accounts table, right? So if I run this, what will happen? The income flag is showing 1. How? If you go here, this income less than 20,000 will return a boolean. It's 0 or 1, like true or false. The first record, it will check. Where is it? So the first record, it will check if the salary is less than 20,000. No. So it brings up 0. The second one, it check if it's less than 20,000. Yes. So it brings up 1. So the condition itself is going to return 0 or 1, right? The boolean for. So I am going to take the sum of the value. So whichever account is satisfying this condition, it's going to bring the value as 1. If not, 0. Since it's a hard-coded value, you don't have to do the group by. Even if you do the group by, it's not going to harm. But I don't have to do the group by because this is a hard-coded value, right? So I don't have to bring it. So I just eliminate the group by. You should not be surprised like I use aggregation function. Why not group by? Because this is a hard-coded value. Okay. Now I got the first part of it. The same way I can use for the second part also. So I will say sum of income between this and union all. Let me delete this. And union all for the third one, which I will say sum of the income greater than 1,000 from accounts table. So I have to use the accounts table 3 times, but still the query is going to be simple than before. I get the same result, but if you see with the previous one, we have a separate select statement for the column and then you hard coding it. Here you do the select statement for both the categories and then use that as from the table. So the advantage of this third and fourth approach is the query is simple and explainable. Okay, so everything is a separate takeover. So you don't have to use the hard-coded table. We just use the hard-coded value as a one of the columns. But the previous first two, we hard-coded a table itself and then use that as a main table and left join with the given data. So you can go through it. I prefer the second option, which is much easier, but the data is small or the interview point of view, you can use the third or I prefer the fourth one. It's based on your choice. Hope you like this video and thanks for watching.